Hello everyone. Now we are going to study about the numerical solution of ordinary differential equation by using modify Euler method. Now, if we consider the first order differential equation dy by dx is equal to f of xy, function of xy, with the condition y is equal to y0 and x is equal to x0. And we have to find out the value of y at x is equal to p x at p. Then we have to first take the interval h, which is equal to xp minus x0 upon number of partition. Suppose the value is given x0 is equal to 0 and we have to find out the value at xp is equal to 1. So the partition is according to the 1 minus 0 upon, suppose we have partition 5, then the value of h is equal to 0.25, 0.20. That means we will find the solution. First 0 is given, then we will go for the 0.2, then 0.4, then 0.6, then 0.8, and finally we will get the solution at 1. So we have these steps to calculate. For calculating these, first we use Euler formula. Yn plus 1 is equal to yn plus h into function of xn plus xn yn, and then the modification part is yn plus 1 is equal to yn plus h by 2 function of xn plus 1. Till here it is just a Euler formula. Then modification part is plus, the average is, the plus is f of xn plus 1 yn plus 1. We are going to use this formula simultaneously. That means first we will use this formula, equation A, so that we will get the value of yn plus 1, and then this value yn plus 1 will be used over here to find out the modified part of that solution. Now by using Picard's method, find the solution of dy by dx is equal to x plus y square, where the given condition is y0 is equal to 1. Find the value of y at x is equal to 0.1. So over here x0 is equal to 0 and y0 is equal to 1. So x0 is 0. If we take h 0.05, then the x1, next step after adding h in x0, x1 is equal to x0 plus h will be equal to 0.05, and similarly x2 is equal to x1 plus h, that means 0.05 plus 0.05, that means 1. This is the place where we required the solution, and this is the place where initial condition is given. That means we have to calculate for x1 and x2, and because it is an iteration process, so first we have to find out the value of x1, then we will go for x2. So by the formula of modify Euler method, y x f of xy is equal to x plus y square, x0 is 0, y0 is 1, and we have taken the h 0.05. So for the value of y at 0.05, that means y at x1 is, by formula yn plus 1 is equal to yn plus h xn plus yn square. This is the function x plus y square. So we will get yn. If we consider n is equal to 0, then y1 is equal to y0 plus h into x0 plus y0 square. Substituting the value of y0, that is 1. Substituting the value of y0, this y0, that is 1, h 0.05, x square, sorry, x0, and again substituting the y0, we will have y1 is equal to 1.05. I have written this by calculating the terms. Now we will go for yn plus 1. This is the formula from modified form. Yn plus 1 is equal to yn plus h by 2 into function at xn yn square plus function at n plus 1 x n plus 1 plus y n plus 1 square. So now when we substitute the value in this formula, we require when n is 0, the formula will be y1 is equal to y0 plus h by 2 into x0 plus y0 square plus x1 plus y1 square. Now substituting the values, x0 is over here, I am writing the values again. x0 is 0, y0 is 1, but x1, this x1 is 0.5. After adding h in x0, we get x1, and similarly y1 we have calculated by previous value. This is y1, so value is 1.05. Now substituting these values in this formula, we get y1 is equal to 1.0538125. After substituting these values, I just calculate y1, and this is the actual y1, this is the final y1, and this is the mid y1 which we get by using Euler formula. This y1 is from Euler formula, and this y1 is by modified Euler formula, which formula we are using. That means to calculate the solution by using modified Euler formula, we have to calculate first by Euler formula. Now the y1 means we have y1, that means y1 is at x1, or we can say that x is 0.05 is equal to 1.0538125. Now for the second iteration, this is the first iteration is over. Actually the question is asked, we have to calculate y for x is equal to 0.1. So next we will have again yn plus 1 is equal to yn plus h xn plus yn square. This xn plus yn square is from this function. In each and every question the function will be changed. Like the function I have taken from this part, dy by dx is equal to a function of xy. So I am writing the function xn and yn square. So in this I am taking n is equal to 1 now. So we get y2 is equal to y1 plus h x1 plus y1 square. So substituting these values, the values are given over here. X0 is not required. Now we required x1 and this y1, x1 and this y1. So substituting these values, because I have calculated on this question on a paper, so y2 is equal to 1.10765 by Euler method. This is the y2. For x2 is 0.1. This is for x 0.1. But we require the solution for modified Euler method. So we have to again calculate. For y n plus 1 is equal to yn plus h by 2 into xn plus y n square plus x n plus 1 plus y n plus 1 square. Now substituting these values, when n is equal to 1, we have y2 is equal to y1 plus h by 2 into x1 plus y1 square plus x2 plus y2 square. This y2 we have already calculated on our last page by using Euler formula. So I am just writing the values of these terms. y1 is 1.0538125, x1 is 0.05, x2 is 0.1, and y2 from the Euler formula previously calculated is 1.10765. Substituting all these values in our equation, in this equation we get the value of y2 is equal to 1.16960, which is the required answer for the given question. So y2 is at x2, that is 0.1, for which we have to solve it. Over here we have taken h is equal to 0.05. If the question is suppose we are x0 is 0 and the question is given find the value of x, find the value of y at 1. That means xp is equal to 1, and if you take an h is equal to 0.1, then the number of x is x0 is 0, x1 0.1, x2 is 0.2, and so on till 1. That means we have to calculate these terms 10 times. As the h is reduced, your solution is more accurate. But because we are doing it manually, so you have to take the h sufficiently enough small, which you can easily calculate. Suppose for the same question, if the question is given to me and h is not mentioned in the question, h is not given, then I will take h as 0.25 is sufficient for calculation. Now this is the example number 2, which you have to solve yourself by using modified Euler method, where dy by dx is 2y plus 3 e to the power x. Over here it is clear that last 2 lectures we are solving the same example. I am over here to explain you the method only. So over here the y0 is 0, x0 is 0, and you have to calculate for x is equal to 0.2. That means if you take h is equal to 0.1, that is sufficient, then you will go first x0 is 0 and x1 is equal to x0 plus h, that is 0.1. x1 is 0.1 and finally x2 will be 0.2. You have to calculate for all these. That means first x0 is given, y0 is given. You will go for x1 and y1. First you will calculate y1 by Euler method, then you will calculate by modified Euler method. That will be the final. Then again you will go for x2 and y2, again y2 by Euler method, and the final way you will get the y2 by modified Euler method. By using modified Euler method you will get the final solution. You have to solve this question yourself so that the method will be clear to you. Thank you.